Sketch the graph of r equals sine theta plus cosine theta. This is not a polar equation that we might have memorized. Now, some of us might have done enough examples where we know what this is the equation of. And we could plot some polar points, get enough points, and sketch a graph, but I'm going to suggest something else here. But maybe the most natural thing to do in this modern world is to get a quick picture of it in our graphing calculator. It's not actually my first step often because I don't like using the technology if I don't have to, but I think it's a very natural thing. And I get this picture here, which the calculator is kind of stretching oddly, but I'm getting the impression that this might just be a circle. I'm going to press the window button, and I'm going to make theta step be even smaller than it is now. And I'm going to see if it does a better job of sketching it out. And it looks a little better, but I'm convinced this might be a circle. And since I know more about circles in rectangular coordinates, instead of sticking in polar coordinates, I'm going to convert this to rectangular coordinates. So I'm actually going to multiply both sides by r. And on that right-hand side, I have to distribute the r. And so here I have x squared plus y squared. And on the right-hand side, I have y plus x. Getting everything on one side, I see the equation of a circle in its general form, and I'm going to proceed by completing the square. Minus 1 divided by 2 is minus 1/2. Squared is 1/4. And I'll repeat that here. If I'm adding 1/4 and 1/4 to this side, I have to do it to the other side, which of course is just adding 1/2. Do some light factoring. And now I have the equation of a circle in its standard form. And in fact, I can tell you that the center of that circle is at 1/2, 1/2. And that the radius of that circle is the square root of 1/2, which we know is root 2 over 2. So I think I'm ready to sketch the graph of this circle using those facts. So let's imagine a rectangular grid now. And 1/2, 1/2 can be that point. And now my radius, root 2 over 2, that's about 0.707. So a little bit more than a half, but less than a whole. So I'm going to go out just a little further here. There would be 1.5 and 2. 1.5 and 2. Minus a half, minus 1. Minus a half, minus 1. So my little tick marks here are halves, and that makes this a whole and this 2. And if I was grading your papers, I'd want that labeled, so I should probably label it here. So I have my center at 1/2, 1/2, and now I'm ready to imagine drawing the circle. So I need to go to about 0.707. Well, 1 would be here, 0.75 would be here, so maybe just about there. Let's see, 1 would be there, 0.75, maybe about there. Just trying to draw a circle around that point that has a radius of the square root of root 2 over 2. The square root of 2 over 2. And something like that. And I was going to make a comment that I did a little bit better than the calculator, but I really didn't. But because I converted to rectangular coordinates, well, I certainly know that this was the equation of a circle the whole time. And I can compare my graph to that of the graphing calculator, and well, maybe mine should be a little rounder than it is, but I think that's good enough for now.